In our chapter 22, section 4, we have a new topic called organic reactions. What are the organic reactions which we can discuss? And what are their importance to us? First, we must know the types. Our objective from that lesson is to know the types of organic reactions and have the mechanism, or how can these reactions occur. So we will begin our reactions with a reaction called substitution reaction. What is substitution reaction and how can it occur? So my organic reactions, I have many examples, like substitution, like number 2, addition reactions. Number 3, condensation reactions, and we have elimination reaction. We have also polymerization reaction, or formation of polymers. All these are types of my organic reactions. So what about the substitution reaction? We will take the first. We have substitution, addition, condensation, elimination, and polymerization reactions. So we will begin with substitution reactions. What are substitutions in organic chemistry? Substitution reactions is one in which one or more atoms replace another atom or group of atoms. That is the substitution reaction. If I have an example like that, like CH4 is a methane, and I have chlorine, Cl2 is my gas, Cl2 is chlorine gas. And the chlorine, when we reach by energy to break down the bonds, so the chlorine can substitute hydrogen and produce CH3Cl plus HCl. That's a substitution, because one chlorine substitute instead of one hydrogen. So it is a substitution reaction. I can complete that reaction at the next slide if I have CH3Cl plus Cl2. Also, it is another substitution. Since I can substitute another hydrogen with another chlorine, it is very strong reaction, and it occurs with something like a little explosion or something. It's very strong reaction, and it is a substitution of hydrogen with chlorine. So dichloromethane is my product. It is called dichloromethane. Dichloro, I have 2 chlorine, dichloro, and C in the middle is for methane, dichloromethane. Also, I can complete that. I can bring the dichloromethane with another Cl2 and so on, with another Cl2 to get Cl, and H. That's the chloroform. Also, I can add Cl2 again, and I can get C. That's another substitution. So each hydrogen is substituted with one chlorine. So it is kept tetrachloromethane. That compound is called tetra for chlorine. Tetrachloromethane. Tetrachloromethane. That's my final product. Tetrachloromethane. If I have dichloro or tetrachloromethane with HF in page 701, you will find that example. I have CCl, Cl, Cl, and Cl with HF. I can substitute that and produce F plus, here Cl is still the same, Cl, and plus bi-binary is HCl, so HCl. Trichlorofluoromethane, that's my product, trichlorofluoromethane. And I can get trichlorofluoromethane with another HF, trichlorofluoromethane with another HF to produce, H will take another Cl and produce binary HCl, but the main compound is C-methane with Cl with another F here and the F here and Cl here. Dichloro and difluoromethane. That's my final product. Dichloro, and these compounds are called ferrions, as we had known before. Now that is an example for substitution. What about the addition? Second is another type of reactions called addition reactions. What about the addition reaction? Additions, it means add any atoms like X2. X2, it means XX. XX, it means like H2. H2, it means HH. To the double bond. If you add H2 or X2 to the double bond, so you need to break down the double bond to make the addition. If you want to add H2, so it will be H here added, and you break the bi bond, that is a sigma called the sigma, and it's called the bi, weak bond, it will be broken, and it will be like that. So your hydrogen will be added like that, and you break the bonds. So that's your addition reaction. From unsaturated double bond to saturated single bond. That's contain double, it's called the unsaturated to saturated single bond. So the addition reaction, parts of the molecule are added to unsaturated to change it to saturated, from the double to the single. From the unsaturated compound, the unsaturated, to that became saturated. Saturated, it means single bond, as you see. You break the bi bond in the double bond and you change it into single bond. From unsaturated to saturated, that is the addition reaction. So if you have any double bond, like if you have, as in the example in your book, if I have C double bond, C, and like that, if I have an example like that, and C, and that's bonds, C double bond, C here, that slash, it means a hydrogen, and I have C, I have here these, I have two double bonds here. So if I add here one molecule of hydrogen, it means H2. So two atoms of hydrogen will be added. I have two double bonds, one double bond and the second one double bond. I have two double bonds. So we will add the molecule of hydrogen to one of them. So I can break that down and it will be changed from double to single, as we learned in the previous example. We added H2 to that double bond. What about the second double bond? You need another molecule of hydrogen, H2. So you need two molecules of H2, I can write down that we add 2H2, 2 molecules of hydrogen, to break these double bonds into single bonds, as the example in your book. If you want to break one double bond, add 1 molecule of hydrogen. If you want to break these 2 double bonds, you want two molecules of hydrogen to change the molecule from unsaturated to saturated single bonds. What about the third type, condensation? Condensation reaction. Condensation reaction is an organic reaction in which it's related to organic chemistry only. Condensation is one in which 2 molecules or parts of the same molecule combine. I can add A to B to produce AB, but the addition need to extract something, to break down something from A and B, small molecule. It's called a small molecule or byproduct comes out from AB. How that occur? If I have amino acid NH, that's amino or amino. Some people call it amino, but usually it is amino. So if we have that amino acids like that, C double bond O, OH, and another amino acid is NHH. That's R. But the other one, difference is the other one is R dash. That's the difference. In your book, that example existed, and so it is C double bond O, OH. So if we want to add them to each other, we must extract, we must get a small molecule, as we said before. Our small molecule, when we break that bond, so our small molecule is HOH. HOH is H2O, is the molecule of water. So minus that molecule, or you get that molecule out. So your products will be addition of that amino acid to that amino acid. So you will get them beside each other in one molecule, and you will get your water molecule out. It is called like peptide. You have NHH and you have NHC, and you will have H here and R, C double bond O, and you will have C double bond O. That's you. It is called peptide group. You will have here the rest of the molecule. So NHCr dash and HC double bond OH. That's the whole compound. It is called dipeptide. It is very important for proteins and so on. But that's because it is a condensation of amino acids with each other, as you know that in biology. What is the next type of reaction? It's called elimination reaction. It's called elimination. It is the third, I think. It is the third type of reaction. It is called fourth. Sorry, this is fourth type. Our fourth type is elimination reaction. What about elimination? Elimination reaction, it means when you eliminate, when you get an element like hydrogen or a molecule out from a compound. Elimination reaction, it means, is one of the reaction in which a molecule of water or ammonia is formed from adjacent carbon. How can elimination occur? If I have compound X, like that, H and H, that's it. So that's my organic compound. If I can eliminate XY, eliminate it means extract XY out from the compound. So elimination, it means the formation of XY as a bi compound, and we break these bonds and we will form double bond instead. We will form here, instead of single bond, we form a double bonds. So it is elimination reaction. Elimination of XY. It means extraction of XY out from my organic compound. So it is an elimination. Eliminate, it means maybe minus or something. So elimination reaction is one in which the simple molecule like water or ammonia is formed and the adjacent carbon are combined with each other. We will take example of elimination reaction. Example of elimination reaction. Example of elimination. Example of elimination reaction. Our example is ethanol. You know ethanol, CH3, COH, that's the ethanol. When we put dehydration substance, sulfuric acid, it eliminates water, it can extract water, it can absorb water from the compound. So I want to absorb water here. I take the hydroxide from one carbon and the hydrogen from the other carbon in that ethanol, CH3, CH2OH. We will take HOH and we will form a byproduct of water. That's elimination of water. And we will form a bond between the carbon with each other like that. So when we eliminate H, we break down that. When we eliminate OH, we break down that. So the two electrons form one bond. I have here from ethanol, that's called ethanol. I can get ethene. A double bond by elimination of H2O or HOH, because HOH, when it is eliminated, extracts out from the compound, it produces my ethene. That's my example for elimination reaction.